Hey everybody, Mr. Smith here. Welcome to a new video. In this video, we're going to talk about graphing a quadratic equation in standard form. So, briefly, let's get through a couple of need to knows about quadratic equations and what those are. Quadratic equations are just equations that have a squared term in them, just like we have here. All right, and when it looks like this, it's ax squared plus bx plus c. If the quadratic equation is written in that form, we say that it is written in standard form. So that's the type of quadratic equation that we're going to be dealing with in this video. Just for clarity, the a, the b, and the c, those are just coefficients, so those can be any number, right? They can be a 5, they can be a 1, they can be negative, they can be anything. Those are just coefficients that change based on the equation that we're looking at. Let's also talk about the graph that these things make. They make something called a parabola. So shape of a parabola looks something like that. Looks like a U or a half pipe or something like that. There are a few important pieces to a parabola that we need to be familiar with. The first is kind of this middle point. Okay, it's either the bottom or the top if your parabola opens down. We call this point the vertex. Okay, so that's an important part of a parabola. It's the halfway point essentially. We also have the line that goes through the vertex. It splits the parabola in half. We call this the axis of symmetry. Okay, we call that the axis of symmetry because if you flip the parabola around over this line, it's symmetric. One half of the parabola is the same as the other half of the parabola. So those are a few important things that we need to deal with when we're talking about parabolas. Parabolas can also open down like this. That's totally fine. In that case, the vertex is on top up here. Okay, so your vertex is either your lowest point or your highest point. It's either like the top of the mountain or the bottom of the valley. Okay, we're going to talk about these things more as we move forward. So let's talk about standard form in a little bit more detail and kind of the intricacies of it. The graph of the function in standard form opens up when the a value is positive. So what does that mean? If the leading coefficient, the a value in your function, the very first number, if that's positive, meaning there's no negative sign in front, that means your graph opens up, like this drawing right here. Okay, it's opening up. Yeah, so if the a value is positive, that means we open up. Okay, and think about whether or not you have a maximum or minimum value. In the case of a parabola opening up, you have a bottom point, right? So that means you have a minimum value. Your vertex is your minimum value. In the case of the parabola opening down, you have a top part, meaning you have a maximum value. The vertex is on top, meaning you have a maximum. Okay. The graph opens down, kind of the alternative case, the graph will open down when the a value is negative. So in this case, for the graph opening down, maybe your function looks like that. I'm just making that up, but notice how the first term is a negative number. That would mean the graph is opening down. So you can determine whether or not your graph has a maximum or a minimum value simply by looking at the very first number, seeing if it opens up or down. Okay. The axis of symmetry. Remember, that's the line that cuts the parabola in half. It's really important. The axis of symmetry of the graph is found using this equation x equals negative b over 2a. It's x equals because the axis of symmetry is a point that is on the x-axis, and we'll see that in a little bit more detail coming up. But this equation right here is really important. We're going to use that a lot. Okay, so like I just said, the axis of symmetry is the x-coordinate. It's on the x-axis. It is the x-coordinate of the vertex. So the vertex of the parabola is, again, this halfway point. The axis of symmetry goes straight through the vertex. All right, so the vertex is a point. it's got an x and a y value. The x value is simply the axis of symmetry. The y value we have to find by plugging in the axis of symmetry into the function. Okay, so I'm going to do one example of putting this all together to graph one of these things. It may seem like a lot of information up front, but it's actually not that bad once we start moving through the steps. So it's asking me to graph this. It's asking me to graph this quadratic equation. Okay, and it's going to give me everything I need. I need to tell whether or not it has a maximum or minimum value. I need to find the axis of symmetry. I need to find the vertex, and then I'll show you how to get the rest of the graph. Okay. So to determine whether or not it's a maximum or minimum, remember I said all you have to do is look at the very first thing, the leading coefficient, and ask, is that positive or negative? Well, the leading coefficient is 1, because there's nothing written there, so there's that imaginary 1. And it is not negative. There's no negative sign. So since it's positive, that means the graph opens up. So my graph looks like this. That's what its shape is going to look like. Now that means that the vertex is down here in the bottom. It's like the bottom of the valley. So I got to ask myself, is that a maximum? Is that a high point, or is that a low point? Well, clearly I can just see visually that it's a low point. So that means that this graph has a minimum value because it opens up. Okay, so you can just kind of logic your way through that. Now let's find the axis of symmetry. So we're going to find the axis of symmetry now. Remember, I have to use this equation, x equals negative b over 2a. So let's write that over here. X equals negative b over 2a. Well, let's label all of our coefficients. It's a, b, and c. I'm just going to take each of these things and put them into the equation where they're supposed to go. So negative b, well, b is 6 right now, but I need to make it negative, so it's going to be negative 6 on top over 2 times a, so it's 2 times a, which we already determined is 1. Okay, now I'm just going to evaluate this and see what I end up with. 2 times 1 is 2, so it's negative 6 divided by 2, which is negative 3. So that means my axis of symmetry is negative 3. Okay, so that means my axis of symmetry on this parabola is going to be at x equals negative 3. Here's the x-axis. I'm going to go to negative 3. And here's my axis of symmetry. That's going to be the line that cuts my parabola in half. Okay, so now let's figure out how we actually get the points on our parabola to graph. The easiest way to do it is to just plug points into a table. Okay, so I'm going to show you what that means. I'm going to take the axis of symmetry and put that right in the middle of my table. It's an x value of negative 3, so I'm going to put that right in the middle. And then I'm going to build up my table around it. So I'm going to do 2 points that are bigger and 2 points that are smaller in order. Okay? So to find the vertex, remember the vertex is a point. It's somewhere on the axis of symmetry. I need a y-coordinate though. In order to find the y-coordinate, I'm going to take the axis of symmetry that I just found, negative 3. I'm going to plug that in to my equation. So it's going to look like this. My equation is x squared plus 6x plus 5. I'm going to replace every x with a negative 3. I'm plugging it in. So it's going to be negative 3 squared plus 6 times negative 3 plus 5. Now I'm just going to do one piece at a time to see what this ends up being. Negative 3 squared, that's negative 3 times negative 3. We get positive 9. 6 times negative 3 is minus 18 plus 5. Okay, so 9 minus 18 is negative 9 plus 5 is negative 4. So that means that the y-coordinate of my vertex is negative 4. When I plug negative 3 into the equation, I get negative 4. That means my vertex is the point negative 3, negative 4. So let's go ahead and mark that. Use different color here. Negative 3, negative 4. There's my vertex. That's going to be the middle point of my parabola. Okay, well, how do we get the other points? We're going to do exactly what we did with the vertex. We're going to take these x coordinates, plug them into my equation to get the corresponding y coordinates. Okay, so let's do negative 2 and negative 1. here's my equation. I'm going to plug in -2 for x because that's the next biggest point. So I'm just going to use that. So I'm going to replace all the x's with -2. It's going to look like this. -2 squared plus 6 times -2 plus 5. -2 squared is 4, positive 4, plus 6 times -2 is a -12, so it's plus -12 plus 5. Well, this is the same thing as minus, so it's 4 minus 12 plus 5. 4 minus 12 is -8. I'm just doing orders of operations here. I did my exponents first, I multiplied, and now I'm just adding and subtracting. So 4 minus 12 is -8. Plus 5 is -3. And if you need to put all that into a calculator, you totally can. So that means when I plug in -2, I get -3. So let's go back to my table. At -2, the y-coordinate is -3. Now let's do -1. I'm going to plug -1 in for x and see what my y value turns out to be. Remember, there's a y equals in front of this whole thing. So I'm going to replace all the x's with -1. That's -1 squared plus 6 times -1 plus 5. -1 times -1 is 1. 6 times -1 is -6. Since we're doing plus -6, remember we can just say that's like -6 plus 5. 1 minus 6 is -5 plus 5. Well, -5 plus 5 just gets me 0. So when I plug in -1, my y-coordinate that corresponds with that is 0. Okay. So now, before you go and do these other 2 points, let's think again about a parabola. This point right here is the vertex. That's the middle point. Okay. On either side of the vertex, the parabola is exactly the same. It's symmetric. So the y-coordinates on this side of the vertex are actually going to be exactly the same on this side of the vertex. So you can actually take a little shortcut. Once you find y-coordinates on one half, all you have to do is switch them down to the other half of the vertex because the parabola is symmetric, so one half is the same as the other. So that means at -4, the y-coordinate is -3, the same as right here. At -5, the y-coordinate is 0. I don't have to go plug those in because I know the parabola is symmetric. Okay, so once you do one half, you automatically get the other half for free. All you have to do is copy it because the parabola is symmetric. All right, so let's go ahead and graph these points, and that'll be about it for graphing this thing. I've already got my vertex plotted right here, so let's plot -2, -3. I got to go back 2, down 3. There's my point. -1, 0 means I go back 1, and then I don't go up. So there's my point. Let's plot these points now. -4, -3, left 4, down 3. -5, 0, left 5, and I don't go up and down. So there's my points. Now I'm just going to do my best to connect these things. I'm not much of an artist, so it won't look great, but I'm sure yours will look better. I just connect the points, continue the pattern going up, and I've got my parabola. Okay, so here's my vertex at -3, -4, just like I said. -3, -4, and here's my axis of symmetry at x equals 3. Okay, so there's an example of how you graph a parabola in standard form. Notice how you might have your a value, your leading coefficient, might not be 1. Okay, if that's the case, nothing changes other than when you do this equation, -b over 2a, your a value is not going to be 1. In this case, it would be 2 or whatever number it is. When you do this equation, you have to pay really close attention to negative signs. If you have a double negative, you got to swap that. You can't lose track of your negatives. Okay. Hopefully this is helpful. If you guys have questions, please let me know, and we'll see you soon.